Good afternoon, everyone. Thank you so much for coming to the Research Exchange talk here at Citrus this afternoon. My name is Camille Crittenden. I'm Deputy Director, and I'm very pleased to welcome you here to Sutardja Hall, our Citrus headquarters, as well as to our remote viewers at other Citrus campuses, UC Santa Cruz, Merced, and UC Davis. I wanted to mention that we will be recording today's talk and all of the Research Exchange talks, and they'll be made available on YouTube after the event today. But I encourage you to go and just check out the speakers that have appeared here over the last several years. It's quite a great repository of information and current research on different topics related to the citrus areas of research. Just a quick reminder, next Wednesday is Veterans Day, and it's a campus holiday, so we won't be having a research exchange next week. A couple of other just quick announcements before I introduce today's speaker. This Friday, there will be a conference at UCSF co-sponsored by Citrus and the Health Initiative, the Berkeley Haas Healthcare Conference, which will focus on how technology, innovation, and design are changing the future of healthcare. So visit the website at www.haashealthcareconference.org to learn more, and registration is available there. On November 17th, so in a couple of weeks, we'll be hosting a couple of folks from IBM to talk about the Watson platform and the Bluemix suite of applications. So it will be, that's a Tuesday afternoon, but also lunch will be available, so it'll be a similar setup to this. I think it will be a great opportunity for us to learn more about the Watson platform and the Bluemix tools. We're hoping to use this also as an opportunity to launch the Citrus Mobile App Challenge, which will be kicking off in early 2016. So I encourage you to take a look. There's also registration available for that on the Citrus website. So come and learn more from our friends at IBM about Watson and Bluemix. Finally, the Big Ideas competition is now open for proposals. The pre-proposal deadline is November 12th. So you probably know about this program sponsored by our friends at the Blum Center across the way. This is mostly for students or others who are affiliated with UC, most of the UCs, actually, any of the campuses, to contribute big ideas about solving social problems in various ways. And one of the categories is IT for Society. So that's one that Citrus is sponsoring and has been involved in helping to encourage and coach the student teams. But it's a wonderful program, so take a look at that. I'm really delighted to have Louis Fox with us here today to talk about CENIC. He's the president and CEO of the Corporation for Education Network Initiatives in California, so CENIC is the acronym. It's a nonprofit corporation and represents the common interests of California's education and research communities in achieving robust, high-capacity, next-generation internet communications services. So clearly there's a lot of crossover with some of the big data initiatives here on campus and elsewhere, as well as with the Pacific Research Platform that we are working with Cal IT2 to develop. Prior to joining CENIC 2 years ago, Louis served for nearly 3 decades as a faculty member, researcher, and senior administrator at the University of Washington and at Duke University. Please join me in welcoming Dr. Louis Fox.
Thank you, Camille. Well, it's great to be on campus. I have the great good fortune to live in Berkeley, but I don't get to spend much time on the campus. I seem to spend time everywhere else in California besides Berkeley. I wanted to talk about a couple of things today. One is about CENIC in general, who we are and what we do and why we do it. And then more specifically about a couple of projects that I thought might be of interest. But before I do that, I want to see, are all of you somehow affiliated with Berkeley in here? Raise your hand if you're affiliated with Berkeley. Anybody from the community, broader community? Okay, great. And from yes, across the water community as well. Yeah, okay. Great. Those of you who are at a CENIC-affiliated institution, whether or not you know it, you're very often on our network. CENIC's mission is really to focus on providing a world-class network for innovation, collaboration, and economic growth. We were chartered by our members, and we have 6 charter associates. The California K-12 system, represented by the California Department of Education. The California Community Colleges, represented by the Chancellor's Office. California State University system, again, represented by their Chancellor's Office. 3 private universities, Stanford, Caltech, and USC. University of California, represented by the Office of the President. And the California Public Libraries, represented by the California State Library. We're a 50c3 organization, and we are governed by our members. It's a little bit like Noah's Ark, but instead of coming 2 by 2, they come 3 by 3. So the President of the University of California appoints 3 representatives, and the Chancellor of the community colleges appoints 3 representatives, and so on. And the infrastructure that we have and the services we provide are in fact, driven by the needs of these communities up here, and are really owned by those communities. CENIC came together about 20 years ago. When there were separate networks for all of these different educational segments, or no network at all for some of them, and brought everybody together into a common infrastructure. And it's one of those places in California where the broadest education community comes together and works in really productive ways. What we do is related to fiber. Fiber is really the physical substrate for our work, and I was thinking about taking you on a tour of the telephone poles at Berkeley, so that you could see how it works in a city that is so resolute in adhering to 19th century infrastructure to support 21st century infrastructure. Other cities put a lot more of their fiber in the ground than this one. Even cities that don't have as many earthquake hazards as the Bay Area. And this fiber not only needs to get across the city, but across the country. That's a very stylized map of infrastructure in the U.S. There's a considerable more than that, but a lot of the private sector companies treat their maps of infrastructure as a trade secret. So it isn't always clear where, in fact, this infrastructure exists in a given area. Although organizations like mine are able to get fiber maps under non-disclosure agreements, and so we do have a better idea than most of where some of the infrastructure is. And then subsequently across oceans, and I'll talk a little bit more about the oceans. By the way, just as the infrastructure, fiber infrastructure follows railroads and telegraph lines and so on, a lot of the transoceanic cable follows originally telegraph transoceanic cables. There's a wonderful book that I commend to you called The Victorian Internet that covers a lot of this. Scenic has about 3,800 miles of optical fiber in the state, a long-haul optical fiber, as well as municipal fiber in various areas of the state. We have about 10,000 institutions that connect to us. And it's hard to actually estimate how many people use the network, but we assume it's somewhere in the neighborhood of 20 million Californians, especially once all of the fiber to the 1,200 public libraries in California is lit. As I mentioned earlier, we're governed by members at the segmental level, and we work with with over 500 private sector partners. This is sort of our subway map of Scenic, and Scenic really has 3 network layers. There's what we call the Digital California layer, and that really is the daily use California-wide intranet. There's the high-performance research layer for communities like this one and the other research institutions around the state. And then there's a breakable network layer, the experimental layer, for those folks who need to work in network-related research, but we probably don't want them to break the production network that we use for those 20 million people. This network connects to other infrastructures, and I'm going to talk a little bit about this. For us, we connect not only to all these institutions in California, but we directly interconnect with 88 other major networks, so that the traffic from our network doesn't need to go across the commodity internet, but directly to these peering partners. And it also enables collaboration with these companies and these other networks. Here's a newer map of that gives you some sense of especially the research and education networks that we peer with. We've developed nodes of our network in a variety of places in the West. And you'll see it to the right over here. We're lit to El Paso, Albuquerque, Denver, Chicago, back to Seattle, and all the way back down to Los Angeles, as well as to Vancouver, and through Tijuana to other parts of Mexico. With our sister organization in the Pacific Northwest called the Pacific Northwest Gigapop, we run an international and national peering fabric called Pacific Wave, which allows researchers in California to collaborate over these research infrastructures with their colleagues in the Asia-Pacific region, and then through our partnership with Starlight in Chicago with European networks and beyond. One thing I do want to point out here, and which we were delighted to announce a couple of weeks ago, you'll see that we now have a 100 gigabit connection from Pacific Wave to Tokyo. We'll be lighting up another 100 gigabit connection after the first of the year from CENIC in Tokyo to Los Angeles. It's very likely that Internet 2 will have a connection from Singapore to Los Angeles. And we're in conversation now with our colleagues in Japan, Singapore, and at the National Science Foundation of closing the loop between Singapore and Tokyo, so that we'd have a trans-Pacific loop. And, and it would allow some of the networks in the Asia-Pacific region that for whom a 100 gig link is just exorbitant to simply connect to this peering fabric and thereby to the networks in the US and beyond. Our colleagues in Australia, that's a 40 gig trans-Pacific link that'll soon be upgraded to 100 gigs, in large part in preparation for the square kilometer array of radio telescopes in Australia. So it is a fairly robust Western infrastructure connecting our research institutions to the rest of the institutions in the world. I wanted to go through this because CENIC doesn't do something that other states, other states have their CENIC kinds of entities. They tend maybe not to have as many members as we do in California, or maybe to not be as heterogeneous as we are. Ohio has a similar network. There's a network in California that's probably North Carolina that's similar to CENIC in that it goes all the way from K-12 to research institutions, academic medical centers, and so on. Florida has a network. And Florida is a very important peering place, Florida International University, for Central and South America and for the Caribbean. But the Florida network really focuses on the research universities in Florida, and not on the broader community as we do here in California. And Texas, again, Texas is focused mostly on the higher education network. This is a map of the regional networks. A lot of the maps are considerably out of date. And in fact, as a result of doing this presentation, I've nudged a number of our colleagues to update their maps because they are wildly out of date. For instance, even the Scenic map, because, as I said, we're lit to El Paso and Albuquerque, Denver, Chicago. For my money, the most important research network, national research network in the U.S. is the Energy Sciences Network, which happily is located here on the Berkeley campus at Lawrence Berkeley Lab. And I think they are really the leaders for the country in innovation, in support of research. And we are really delighted to have them as partners. There are other national infrastructures, including Internet 2, a membership organization that has about 200 research universities as members and others. We interconnect to them as well, and it's an important infrastructure for the research community in California. And then this is a map that's currently being updated of the Global Lambda Integrated Facility. This is not all of the networks in North America necessarily, but it's a map of the sort of additional capacity that these networks are willing to use in support of international research. And here you see it on a global scale. Again, this is currently being updated. But it means that a researcher on the Berkeley campus, on the Merced campus, on the Santa Cruz campus, or anywhere on any of our research campuses in California has access to these networks and to their colleagues elsewhere in the world. I wanted to note here, since if I go back here, you'll see that there's, it appears that there's no connectivity to Africa. And as somebody who's spent 25, 30 years working and doing research in sub-Saharan Africa, I did want to point out that the European Union has been very forward-thinking in funding connections between Southern and Eastern Africa and Europe, and also intra-Africa connections, because one problem that many African researchers had is they might be at separate institutions in the same country in Uganda or Kenya, but their traffic was going, all the way to Europe or to the U.S. and back to a campus that might be some number of miles away. It made absolutely no sense. There is an increasingly robust commercial infrastructure in Canada, a lot more in Africa, a lot more submarine cables around the east and west coasts. A number of the countries are building out terrestrial infrastructure. There is an organization called UbuntuNet for sub-Saharan Africa that looks at research and education networking in those countries. An organization called CalREN that looks at research and education networking in West Africa. Sadly, our government has yet to do much investing in infrastructure that might connect our U.S. institutions and African research institutions. And I hope to see at least a modicum of funding in the future from the National Science Foundation to enable some more of that connectivity. There are, many innovative, talented, bright faculty and graduate students who are in many ways cut off from the international research community and really do need to be connected there. There are important instruments. The other part of the square kilometer array that I mentioned earlier is going to be in South Africa. And so that's a critical infrastructure for astronomy worldwide that will need to be connected. We use three main strategies, and the three main strategies that sort of characterize the work that we do at CENIC. And I'm going to cover two of these in the rest of the talk. One is to develop the 100 gig network and services and projects like the Pacific Research Program. And the other one is to ensure equity and access across California and across this broad spectrum of educational institutions, both formal and informal, that we connect to. And I thought because Citrus has the society in its title that it would be important to talk about that sort of societal focus that we have. And these are not bifurcated. They actually interrelate. If you think about the environment that you have here at Berkeley, or that your faculty and student colleagues have elsewhere, you're in a technology environment that really, some of it is pre-commercial. It doesn't exist anywhere but in your labs and on this campus. You certainly can't replicate it necessarily in most of your homes. And so it allows you, in effect, to live in the future. And when you see the kinds of research innovations that come out of these institutions, and in fact, if you will, a whole new economy was born of these institutions, we want to replicate that environment across the whole education spectrum so that a community college student in California can have access to that environment, and so that a high school student in Humboldt County can have access to that kind of infrastructure. My sense is that talent is democratically dispersed in populations. The problem is opportunity isn't. And with physical infrastructure like this and with broadband, really ultra-high broadband, we're able to distribute more of that opportunity and have it meet up with talent and let it bear fruit. The other thing, and I'll touch on just briefly at the end, is our interest in including more important social institutions that enrich the network for everyone. We have a bunch of initiatives underway right now, and I'm going to focus on the Gigabit Public Libraries effort and the Pacific Research Platform. But because the economy's been good the last couple of years, we have been able to work with the California State Legislature and get funding for building out infrastructures both for the K-12 community and for the community colleges as well. And we have significant projects in both of those arenas. As I said, I'm going to highlight two projects. The Pacific Research Platform is really an exciting project. And it has leadership from Cal IT2 at UC San Diego and here at Citrus. And the idea is to create this friction-free big data highway across multiple institutions in California and among some partner institutions elsewhere in the US and in the world, and really kind of create a broad-scale effort that resembles what you might have in a computer cluster across multiple campuses. There are really 4 key ingredients to building the Pacific Research Platform. The first is ESNet, the Energy Sciences Network, Lawrence Berkeley Labs, Science DMZ, which I'll talk about in a little more detail, but it was really an important catalyst for bringing this kind of activity together. The second is the 100 gig Scenic network. We did something very different with the latest iteration of our network. Typically, when we upgrade the network, we upgrade it to points of presence, and then we ask the campuses to figure out how to improve their bandwidth to get to those points of presence. What we did this time was we dropped off the 100 gig network at every one of the research institutions in California for them to then focus on upgrading their campus infrastructure, which is a costly and complex thing to do, which brings us to the next program, which is the National Science Foundation's programs that allowed campuses to invest in upgrading their infrastructure so they could make use of this new 100 gig environment. And last and certainly not least is the engagement of scientists in surfacing the requirements for the network so that the engineering community can respond to them. I've always been envious of our colleagues at the Department of Energy who have this conversation in an ongoing way between the engineers and the science community. And we are underway here now among the research institutions in California to sort of replicate that process and have the science requirements drive the next generation of this network. I think one of the mission statements of ESNet really says one of the goals most eloquently for the Pacific Research Platform, which is to have scientific progress completely unconstrained by the physical location of instruments, people, computational resources, or data. So it really doesn't matter where you are and where your resources are, but you have access to all of them as if they were all local. And as I mentioned earlier, the notion is that we have a backplane for data-intensive science. These are the partners in what we call Pacific Research Platform version 1 and 2. I'll mention version 0 earlier, but Larry Smarr at San Diego is the PI, and Camille here is one of the co-PIs, along with Tom DeFonte and Phil Papadopoulos, and you see another colleague from the physics department. These are the participating campuses, as well as Department of Energy labs, NASA. You'll see a list over here, University of Hawaii System, Montana State University, Northwestern, the National Center for Atmospheric Resources and Research, and so on. We do have some international partners too, the Australians at ARNet, the Koreans at KISTI University and the University of Tokyo. So it's a good set of partners to work on creating this new infrastructure that supports science. The grant from the National Science Foundation is an important way to plant a flag. It does support a modest amount of what goes on, but more importantly, there are engineers and scientists who, quite apart from their day jobs, are pretty deeply involved in this. I see these engineering calls every week, and there's anywhere from 20 to 50 really busy engineers and research universities and at ESNet who are on these calls because they think it's something very, very important and really quite exciting to do. The Science DMZ here, you'll see the 4 key concepts. I mean, the notion here is to create this frictionless environment for researchers that is dedicated to data transfer, where we can measure performance and where it's a secure and shared sort of trust fabric across these various institutions and these various scientific communities. One piece of this is the appliance that allows you to connect to this 100 gig environment in your lab or for your scientific instrument. And the folks at San Diego and some of their colleagues have come up with a way to use commercial gear and to do this very inexpensively and to spread these data transfer nodes. This is part of what the National Science Foundation funded around to the participating institutions in the Pacific Research Platform pilot. These are the grants from the National Science Foundation, and I had to write down what these acronyms stand for. Sometimes at the National Science Foundation there will be one program manager that has an impressive impact on what goes on in the scientific community. And in this case, it's a fellow named Kevin Thompson, who really has been the spirit, the energy, the thinking, who's really spearheaded these efforts for both the campus-related infrastructure improvement grants, the grant that funded the multi-campus effort that Citrus and Cal IT2 are a part of, as well as the international networking efforts in the US. And I think he gets a certain perverse joy out of changing the names of these things every year. So they're all campus cyber infrastructure, that's the CC. And then the first one of these was infrastructure, innovation, and engineering. The second iteration was networking, infrastructure, and engineering. And this last one is data, networking, and innovation. So that's what those acronyms stand for. And these are all the places that they've been funded. You'll see that there's been a real concentration of funding to these efforts in California. The science drivers and the science participants in this Pacific Research Platform version 1 are up here, the particle physics, astronomy and astrophysics, and you'll see the projects there, biomedical data analysis, earth science, and a number of different earth science projects. And again, with scientists from across University of California, Stanford, Caltech, USC, and San Diego State, along with some colleagues from Lawrence Berkeley lab, from NASA Ames, from the institutions that I had up earlier here, like the National Center for Atmospheric Research and so on. So it's a really impressive group of scientists. We had a kickoff meeting with the science community and the engineering community a couple of weeks ago at UC San Diego. And it was a fabulous conversation and a great way to get the project started. As I mentioned earlier, one of the critical pieces is up at the top here, and this is a really great distilled version of what's necessary to do the kind of work for the Pacific Research Platform, but the engagement piece and the engagement of the science community, and that's the effort that Camille and Citrus are leading, along with the measurement, the data transfer nodes, and the science DMZ. We really, I think, as a research community, and particularly those of us who are in the research and education networking community, owe a great debt of gratitude to the Energy Sciences Network for their remarkable work in this arena. There was Pacific Research Platform version 0, which started before the NSF grant, some of which was funded by the UC Office of the President, that allowed the networking community to come together and to begin to build the infrastructure that would allow sort of disk-to-disk transfer. I mean, typically in the networking world, we talk about networking speeds, which are kind of irrelevant to a scientist. I mean, they really want to figure out how it's going to work in their lab from wherever the resource is. And it was pretty impressive for a first go-around. These are, I'm not quite sure, this is a slide from Larry, I'm not quite sure why big data flows add to commodity internet. I mean, we're really using a private internet for this, but I would say that the 100 gig pipes that we bring into the campuses both serve commodity internet needs and they serve research needs, and I'm pretty sure that's what he had in mind. The scientific instruments, access to scientific instruments is a critical piece. Access to remote data repositories, supercomputing data to local users, and enabling remote collaborations. The kind of which, have you all been to CalIT too and seen their toys? They have some of the best anywhere. It's fascinating to see these remote collaborations between, in this case, it's between a lab at the University of Illinois Chicago and UC San Diego. Or in this case, it's between University in Sydney, one in Melbourne, and one in Chicago. Fabulous resources that allow scientists to collaborate in real time with spectacular visualization tools. I'm not going to go into great detail about what we've done here. in part because I look around the audience, and many of you will know this much better than I do. But for a purely volunteer effort for a year, there's been remarkable progress. And now it has a modicum of funding. And I hope the future year's progress, which you'll see the goals for, and the year really started in September when the grant was funded. So you see the goals for the first 2 years, and then the goals for the subsequent 3 years up on the screens. And we hope that this will be a scalable infrastructure, and that many institutions across the United States and across the world will join us in this journey to develop this infrastructure, because it will only be meaningful, in fact, when the broadest research community is using this common infrastructure. I'm going to switch gears now for a sec and talk about public libraries quickly. We do have an initiative to connect all of the 1,112 public libraries in California to the Scenic backbone. We have a number of partners who are working in this. The California State Library, sort of an aggregator for libraries called Khalifa, and a consortium in Southern California who are the recipient of an appropriation from the state legislature to allow libraries to have access to new hardware. Most of them are going from megabit connections to a gigabit environment, and almost all libraries need a pretty significant hardware upgrade. We did some research a couple of years ago, and we discovered that 3/4 of the California libraries probably have less bandwidth than you do at home, if you're here in Berkeley. A lot of them were on T1 lines. There were a number of them that were on fractional T1 lines, and they were serving dozens, if not hundreds, of library patrons a day with that connectivity. They were almost always at capacity, and they were paying really exorbitant amount of money for this low capacity. And most of them were not taking advantage of federal subsidies or state subsidies. And one of the things that we do at Scenic is we run a consortium that allows the K-12 community to access universal services funds that you all pay on your phone bills for E-rate. And it's a very Byzantine process. We run the process. We bid out the circuits to connect them to the network. We deploy the circuits. We do all the federal paperwork and so on. We're doing the same thing for the library community in California, which makes these funds much more accessible. And many of these libraries, as well as K-12 schools, can get up to a 90% federal subsidy for their circuits. And then the other 50% of the remainder is paid by the state of California through something called the California Teleconnect Fund. We've had great luck this first year in connecting libraries. Many of the libraries who've connected to us have gone from megabit connections to gigabit connections. We've seen San Francisco Public Library be the first 10 gigabit library in the world. This year we'll have probably 30 or 40 more library jurisdictions. Library jurisdictions are sort of like a school district. They're sort of the, LA Public Library, for instance, has 80 or so different outlets, and that's a library jurisdiction. And so we work with the 184 library jurisdictions. We'll probably see our first 100 gigabit library jurisdiction in LA City Library. And that'll be an amazing thing. When you think about the cultural resources, cultural repositories that each of those branches are in a city like Los Angeles, which there's no city like it, I think, in the world with that kind of diversity, and the way the libraries are used in that community, and opening up all of those libraries to one another, to the rest of the state and the rest of the country, I think will be of profound value. We do a lot of things for this community. We operate a network operations center. And now libraries are coming into this broader education community that includes research universities, but all the rest of education in California. In the first year, we saw these tremendous increases in bandwidth, but we also saw a decrease in pricing because we aggregate across the library community, and we work with all the providers in the state. And on average, our libraries are paying a third of what they were paying for really crappy bandwidth now for gigabit bandwidth. So it's been a dramatic leap. And even with the 1/3 of the libraries who came in during the first year, we saw about $500,000 come in federal subsidies, which makes the folks in Sacramento quite happy to see us begin to leverage more of the resources that California pays into these federal funds. By the end of this year, we have a year of planning and filing the federal documents and all the rest, and then we start deploying in the fiscal year, which is in July of every year. So the next year or two deployment starts on July 1st, 2016. We will have upwards to 2/3 of the libraries in California connected, and then in the final year of the initiative, we hope to pick up the final third. Lots of reasons to connect libraries. The more successful we are at connecting schools and community colleges, the more acute the digital divide is when these students go home and they don't have access to the internet. And often the library is the only place in the community where they can get access. And you travel around the state to rural communities, and the library may be closed, but people are sitting on the stairs, and then they're in their cars, and they're accessing the broadband network of the library. So it's really a critical place for access. It brings the world into the library, but also allows the world to access the riches of these communities. Just as in universities, it empowers the patrons of the libraries to become creators of content, and it allows the libraries to become, consumers now of a lot more cost-effective services. I just wanted to show you a quick thing that I was mentioning. We're extending the network to other communities, and Mont Allen, who's here from SF Jazz, we've been connecting various scientific and social institutions around the state, and a couple of our leaders are in San Francisco at SF Jazz and the Exploratorium. And this was at a conference that we had last year, and let me see if I can actually get it to play. If not, I have something else that will. So the person playing the piano
right now, one other difference is try not to do any downbeats in the second measure.
The master teacher is in San Francisco at SF Jazz. The instrument that they're using allows each of them to see how the other is playing the piano, like an old-fashioned player piano, to see how they're doing that in real time, and to run a master class this way.
How are we doing on time, folks?
The student who came in there just came in. I mean, it wasn't rehearsed or anything.
We survived.
It was just wonderful to see the kind of opportunity that this sort of capacity allowed for the SF Jazz, and the way to take the expertise of SF Jazz and extend it not just around the state, but potentially around the country and around the world. The other thing that I just wanted to note was we've done some work with the Exploratorium, and they have partnered with the Ocean Observing Initiatives, and particularly the cabled observatories, the fiber optic cable and power that's on the Juan de Fuca tectonic plate that's instrumented about every 50 kilometers. The Exploratorium will have special events where the patrons of the Exploratorium in an informal science center setting will have opportunities to see the kind of science that goes on the seafloor. And there are obviously, in our community, we're sort of interested in these earthquakes, but there's, a whole range of science that goes on with the cabled observatory. And then lastly, this is something that happened a week or so ago at SF Jazz. It was a live performance at SF Jazz that was simulcast to 3 libraries on the peninsula. And I'll just show you a little bit of it.
Because we're trying something new. So I want to tell you something about what we're going to be doing with this performance. First of all, you're not the only audience that's going to be listening to this amazing music. We have, thanks to the modern technology and our friends at CENIC, which stands for the Corporation for Education Network Initiatives in California, and the Peninsula Library System, we're going to be live broadcasting this show to 3 libraries down the peninsula. So we're going to be able to see them on this screen. Woohoo! How about that? Modern technology, folks. It's amazing. This is the first time we're trying this at SF Jazz, so you guys are all part of an amazing experiment. Okay? So right after the concert, we're going to have students from SF Jazz Center and our 3 public libraries in the peninsula take turns asking questions of the members of the band. And so we would like to get the folks out at these libraries.
I couldn't reach it. I was
just they played,
really tiny.
and this will be on YouTube.
A hobby of mine.
And then it's a matinee, a family matinee, and students both in the audience at SF Jazz and in libraries had an opportunity to interact with the musicians on stage. But it really suggests the kinds of things that are possible, not just in scientific domains, but in cultural domains as well.
We were wondering about...
And with that...
Thank you. That was really a wonderful and rich presentation. There's a lot to think about there. I know that most people have to leave right at 1, but we might have time for one question. If there's one burning thing that bubbles to the top of your mind that you want to take an opportunity to pose. If not, I imagine Louis might have a few minutes.
Yes.
Hi. The final couple of slides that you showed, they brought to mind a MOOC, really, but a different way of a massively online open course. Is that something that CENIC will push for also, so that it's, I don't know, do you have anything to say about that?
We sort of do the plumbing, and you guys are the idea folks. So to the extent that there are things that our members want to do, then we'll support them. I mean, there are times when we like to show what's possible, and what we're really hoping for in this is much more verisimilitude, right? So that the experience that you have at one of these off-site centers is as close as we possibly can make it to the experience that someone is having at SF Jazz. The audio is good, the audio in particular, but also the video, and that differs a little bit from MOOCs because a lot of that has been sort of lowest common denominator technology.
Thank you. I was really glad to have to be able to feature Louis and the Scenic program and his great slideshow and information about what all they do, because here at Citrus we do so much about the research that's enabled but relies so heavily upon the networks that Louis and his colleagues are making possible throughout California and indeed around the world. So I'm really grateful for your time to come and share that aspect of the work that we all rely on so much today. Thank you.
Thank you for having me. And I'm if anybody has any questions they want to ask offline, I'm hanging around a little bit too. Thanks.